¿Abro la presentación? Sí, sí.
¿Puede usar este micrófono desde aquí?
Sí, sí.
No, no es necesario hacer esto. Está normal. Pero siempre con micrófono, si no, no se escucha remoto. Por favor. ¿Quiere probar el avance y recetas?
¿Listo?
Usar esto usted para presentarme. Ella puede hablar desde ahí.
Sí, perfecto.
Siempre, si van a participar, siempre tenemos que usar micrófono. Tengo otro de estos.
Sí, para las preguntas, igual María José se hace cargo de un lado y yo del otro.
Ahorita les paso el otro.
Sí, como que sí,
Hay
ok.
que prenderlo.
Sí, aquí está prendido.
¿Quién? ¿Quién es María José?
María José es ella que se puede hacer cargo del otro micrófono y pasarlo de este lado y yo de aquel lado. ¿Sí? ¿Verdad que sí? Esta es mi misión especial.
¿Otro micrófono? Preferentemente lo apagamos cuando no se use.
Sí.
Sí, está apagado, sí. Sí.
¿Esperar a Enrique?
Sí, pues me dijo que estaba en el tráfico. No, sí,
¿Venía para acá?
sí, pero me dijo que me habló que estaba tomado. Yeah, whatever you like, 45, 50 minutes. And questions. Yeah, and then present it very briefly. Yeah. No sé si nos vamos a ver muy ingleses, pero por respeto a los que están aquí a tiempo, vamos a empezar. Les quiero presentar a la doctora María Ferreira dos Santos, que originalmente estudió en la Universidad de Lisboa, en Portugal, que es de donde viene, y tiene diversos diplomados, el doctorado, postdoctorados, en muy diversas áreas. Es una persona en sí interdisciplinaria. Estudió biología originalmente, tiene un doctorado en ecología, pero ha estudiado, eh, preferiría que mejor ella se describa a sí misma, ¿no? Trabaja ahora en la Universidad de Utrecht, está como parte del personal académico de Utrecht y colabora en un programa de maestría en desarrollo sustentable. Entonces, nos va a hablar hoy sobre sus líneas de investigación. Mañana les va a dar clase en el posgrado y va a ser un tema distinto del de hoy, que ya ayer se los habían aclarado en un mensajito. Entonces, qué bueno que estén aquí hoy. Y sobre su evolución a lo largo del tiempo, yo preferiría que ella misma se describa, ¿no? ¿Qué es lo que ha hecho? Nos va a dar la plática en inglés, también entiende español. Si a alguien se le dificulta hacerle alguna pregunta en inglés, se la puede hacer en español. ¿Sí? Entonces, muchas gracias por estar aquí.
Well, first of all, I would like to thank you all for being here, and especially thank you, Amy and Marisa and Lakshmi, for inviting me to come to UNAM and have very exciting conversations over the last few days of what is it that this program is trying to achieve and what is it that we can learn from them, also from Utrecht University and our own programs in sustainability and sustainable development. Today, however, I'm going to give you a little bit of an overview of the types of research that I've been conducting, and this research have been informed from my previous training itself. As Marisa was presenting, I started off as a biologist. I did a master's in environmental science and policy, a PhD in ecology, and 2 graduate certificates, one in business and innovation and one in conservation management. So it's very interdisciplinary. I also worked in a history department and a political science department. So you'll see a little bit of these hints from these different disciplines throughout the presentation. But really what I wanted to focus today is to propose you an idea that I've been working on lately on how can we use remote sensing to really address the spatial and temporal dynamics of social-ecological systems and addressing questions in terms of coevolution of social-ecological systems. So I'd like to start off by having you thinking about biodiversity as a resource. So if you're familiar with the literature on social-ecological systems, you start off with having a resource, and we can frame biodiversity as a resource, and that's really where I have started my research line to think about biodiversity as a resource is a form of communication of why do we need biodiversity and why do humans use biodiversity. And then within the same type of framework, then you can see that one outcome of protecting biodiversity or trying to maintain biodiversity is conservation action, so protection of biodiversity through protected areas. And this conservation action can be seen as an outcome of appropriation and provisioning dilemmas. How much biodiversity do you take out? How much do you provide to maintain biodiversity? And I've been trying to think about this using, I'm sure that many of you in this room are familiar with Elinor Ostrom's framework on social ecological systems, and I've been trying to use this framework to guide a little bit of the research that I've been doing by trying to describe resource units, in this case biodiversity, number of species, however you want to define biodiversity, the resource system, the governance system, and its users. And today what I'm going to show you is some ideas on how can we use remote sensing technology to try to inform or integrate across these different subsystems. A very recent review that was published this year looked into the literature, 120 papers on social ecological systems, and they basically identified that biodiversity is really, although the systems are called social ecological, they really demonstrate that the ecological part is really not well represented in this literature. Most of the literature focuses either in socioeconomics, governance. Well, there's a part of biodiversity if you think about resource productivity, but here we're talking about food and other types of resources or land cover, but really biodiversity in terms of number of species or ecosystem diversity or genetic diversity is really poorly represented in this literature. So I've been trying to think about ways in which we can enhance bringing in this ecology to this framework of social ecological systems. So today, my talk is really about remote sensing opportunities to look into social ecological systems, thinking as biodiversity as the resource. And I'm going to talk a little bit, I'll give you 2 examples on pixels, so more hardcore remote sensing analysis that could be used to inform the resource system. How do we integrate remote sensing with plans, and how do we integrate remote sensing with people? And then I'll conclude and leave some room, hopefully, for discussion. So let's start about pixels. So in my opinion, pixels can help you describe the resource units. So say biodiversity can give you number of species or types of species, their functioning and their different aspects, but can also help you describe the resource system. So how many species are there, how do they interact, what kind of feedbacks do they have. So today I'm going to take you on several tours through space and time. And the first tour that I would like you to take is to back home to my home country in Portugal, where I really started thinking about this system. So this is an oak, this is a oak savanna, and this is home oak, so Quercus ilex. And this landscape has been categorized as a working landscape. A working landscape is really an equivalent to a coupled human-nature system, and in other words, is also a social-ecological system. The reason I focus on this, although I'm thinking about protection and protection of biodiversity, nearly 90% of the Earth is really outside any kind of protection. So we really need to understand these systems as they are not protected and how do they evolve over time. And so within these working landscapes, the consequences of land use and land management decisions really affects what happens in terms of natural system, but also the social system. And biodiversity in these areas will be retained as long as there are certain types of management that are cooperative and encompass the diversity of different uses that you can find in these regions. So in this area, we have a real combination of silvopastoral system where you have agriculture, you have grazeland, you have livestock production, but also what my focus has been is on cork oak woodlands. So these are cork oaks, which are Quercus super, from which the outer bark is extracted to produce cork or corchos. So the cork is used to create cork tops for wine. So that's really where it started from, and this has been a management system that has been put in place for at least 12 centuries in this area of the world, and it has also held very high biodiversity levels. So Mediterranean regions of the world have been identified as biodiversity hotspots, and this identification comes in by quantifying the number of endemic species and the threats to this biodiversity. So this area here is really at this interaction between, it produces very economically viable activity, but it also holds very high biodiversity. Within this context, I studied two systems. I studied my traditional system back in Portugal, and I compared it with a system that has had a much faster history in California. So the landscape in California is also a Mediterranean type landscape, and physiognomically the landscape looks the same, but the land use structure in the system is very different, and the history of use is much more recent, only over the last 150 years. So what I've been trying to do was to first, okay, let's describe the social ecological system in these two systems, and I just went through the whole list of variables that Ostrom has defined as potential for quantifying social ecological systems, and I described them in a very qualitative way for both of the systems. This creates really huge tables, very interesting. The reviewers of the paper thought, oh my. So really what this had informed me was to think about different hypotheses of why these systems can or not be comparable. So if you think about from the social part, we see different interests in terms of economic development and different trends in terms of population density. And then you can think about governance. So you have very different governance structures into these systems that could inform why these social ecological systems may be different. And then you also have slightly similar histories of use, but this can be a point that is argued upon. And then we can think about, even within this framework, there are certain ecological performance measures which can bring biodiversity back into the picture. So then I linked this to another part of my research that is about remote sensing. If you do look into these landscapes, you actually look at them and you see that they are very different. So this is a map of land cover types. So you see that oak woodlands are very dominant, but when you start to look into, this is a map of NDVI, so Normalized Difference Vegetation Index, which maps productivity. You see very much more fine and ingrained differences, and this is a map of plant stress. So what I wanted to try to capture is that, okay, this qualitative description of the social ecological system was not sufficient to me, so I was exploring ways to describe the system in a more spatial way. And to do that, I decided to focus on some key species for this system, so in mesocarnivores, because mesocarnivores have been for a long time used as umbrella species for conservation, because they tend to be area and dispersal limited species. They are associated with ecosystem structuring, they respond to fragmentation, and they have been very useful for conservation planning. So my first attempt to try to spatialize the social ecological system was through creating habitat maps for two key species, the European badger and the American badger, and then creating these maps throughout the year and overlapping them with the different human activities in the system. This was one first approximation of spatializing the social ecological system, and what you can see here that for the study area in Portugal, most of the high quality habitat, which is represented in red colors, overlaps with forestry activities. In California it's slightly different, and it overlaps mostly with agricultural land. I have since then expanded this work because I was thinking, okay, this is a first step to spatializing the social ecological system, but I'm missing some parts of the social system that are not yet fully integrated with the ecological domain that I've explored. So what we've been doing more recently is to use the time series of Landsat to calculate productivity, to try to look into changes in productivity over time and whether they are related to changes in climatic patterns. And what we see first is that there is a trend in productivity. There is a downward trend, so productivity is stabilizing and it's decreasing. And what we see that this productivity is mostly related with a change in relative humidity in the system. And so what this means is that the cork oaks are being more stressed, and this means that the cork itself is losing quality. And so this could mean that the social system will respond to these changes in the cork quality and change the management regime associated with these lands. So that's what really a student of mine is doing her thesis about. So she's been conducting surveys throughout all of the study area, and she's been asking people, okay, so what is your current use of this cork oak landscapes, and has it changed over the last 10 years? Because we wanted to see if the social system was responding to these changes in the natural systems that we were able to measure through remote sensing. So what we see here, different users that live either in a village, so in this location here, in farmhouses scattered throughout the landscape, and people that live in other villages outside of the main study area. So what we see is that cork is mostly extracted by people that don't live in the system itself, and then the people in the village and in the farmhouses use it substantially less. What we see as well is that people have identified a decrease in cork use over the last 10 years, and what we are trying to now explore is whether this decrease in use has to do with the decrease in the cork quality, or it has to do with the decreased demand for cork products, because cork stoppers have been replaced by plastic stoppers for wine, and so we are now exploring this other component of this system. So this is the first example that I'd like to show you today. And now I'm going to jump to another example where we can use remote sensing, and in this case very expensive, very high technology types of remote sensing. The previous example used freely available data, and here I'm going to jump to the Sacramento-San Joaquin River Delta in California, where we have been studying effects of invasive species on native biodiversity and its cascading effect into the social system. So in this case, the California Delta is really a big confusion of different governance systems and problems. It has been modified since the beginning of this century to provide freshwater inputs to several cities in California, but it has been really modified in the last few decades. So the changes to this estuary, they amount to several trends in change. So we see declining sediment supply, we see the changes in the salinity map. So here is the 1937 salinity barrier, and this is the more recent salinity barriers. So water is becoming fresh, and this comes because they want to extract fresh water for different cities. We see decreased primary productivity, and associated with this, and because of its geographical locations, we see accelerating species invasions and decreasing endangered species abundances, endangered fish species abundances. It is within this context that we came in to look into 1,100 square kilometers of waterways, and we were called to try to map the invasive species that occur throughout all of these waterways and to try to assess what are the impacts of these invasive species on the native communities and the different biodiversity that depends on these waterways. So what we did was to collect hyperspectral, very high resolution airborne data over 5 years. So here we're talking about a pixel size of 2 meters and over 200 bands that are collected by this sensor is airborne. Each one of these campaigns costs about $500,000 to collect. And we collected 64 flight lines that cover basically the entire Sacramento-San Joaquin River Delta and used this information. These are about 10 terabytes of data, just this one image here, that we had to process to try to map and develop an algorithm to map invasive species. At the same time of data collection, we collected a lot of field data on the different plant communities from species that live in the riparian areas, through the wetlands, and through the submerged communities. So our suspects that we really wanted to map were 2 particular species of invasive species, the water hyacinth, and the other species that we wanted to map was Brazilian waterweed. So those 2 species were being managed by the California Department of Boating and Waterways, and the reason why they wanted to manage them is because they regulate boating permits and they regulate who gets to fish in this water. And so they wanted to know where they were, how they were spreading, and what could they do to manage these species. So we were able to successfully classify both the floating species and the submerged species at an accuracy of about 90%, and estimated that the floating species, mostly water hyacinth, occupied 5 to 8% of those 1,100 square kilometers of waterways, whereas the submerged species occupied about 12% of the waterways. So it's just to give you an example, so the red are the submerged species, and you can see the progression through time of where these species are. So what we then used this information to do was to look into the ecological effects of such invasive species. So the first thing that we wanted to know was how do these species spread and how do they persist over time. So we are able to look into the different environments over the delta and see how these species grow and see how long do they persist in the system. We then looked into more specifically into the submerged species because a lot of the issues related to the California Delta have to do between this conflict between water rights and endangered species habitat. So what we were asked to do was to look into the factors that determine submerged species cover and how these submerged species may or not interact with the persistence of delta smelt, which is an endangered species of fish about this size. And these endangered species of fish prevents the state from extracting more water from this system. So really these endangered species of fish is really what's determining the management at this level. So what we were able to show is that, yes, there are certain water velocities that control where the submerged species are, and that submerged vegetation tends to limit turbidity. So what we see is that the turbidity that is decreased because of the presence of the submerged species is really within the turbidity range that this endangered species requires for this habitat. This fish is a fish that lives in high turbidity waters, and what we're seeing is that the submerged plant species are decreasing turbidity, therefore decreasing the habitat for the endangered species, and it's creating a management problem. So what we think right now is as SAV expands over the last 30 years, it has promoted sedimentation of a lot of the turbidity in the waterways, and it has created a clearer water. But then we have another problem in here, because invasive species are not just about plants. We have an endangered largemouth bass that was introduced in the California Delta as a fishing trophy, and so there's large fishing tournaments surrounded to who gets to fish more of these fish. They get this big, and people really go out there to try to capture the biggest fish because the trophy is really high. This creates several problems. A lot of these submerged species are transported by boats. So if you have a lot of boats trying to fish these endangered species with boats, they will transport invasive species of submerged plants elsewhere that they were not present first in the delta. And then the other thing is that this invasive species is a visual predator. Therefore, it thrives in waters that have low turbidity. And it seems to like the delta smelt, our little endangered species. So what we have used the remote sensing data to look into was to look into whether the submerged aquatic vegetation cover really was linked to the survival of these invasive species of bass. And what we see is that for both juvenile and adult survival, they are strongly correlated with higher submerged aquatic vegetation cover. So this is a problem because submerged aquatic vegetation is not only decreasing turbidity, making this predator more efficient, but is also improving the population dynamics of these species. And then what we have been working on is what's the likely future for these invasive aquatic species in the submerged land. And we see that the predicted changes given to climate change will enhance the delta in a way that will promote the habitat for submerged aquatic vegetation. So we're really at a stage that we think that these guys will be the dominant community and that the endangered delta smelt will really decrease in this system. So what the state is now trying to figure out is how do you preserve the fish populations, the endangered fish populations, and control these two invasive species. So this was the second example of how can you use remote sensing to inform certain management decisions. I didn't really go into the social part of this, but there has been a very wide array of research that has looked into the social components of these dynamics of invasive species in the delta. Because now I would like to move to two other aspects that I mentioned earlier today that I would be talking about. So the other thing that we can think about is to link remote sensing to plants. And the way I envision this is because these plants somewhat represent the governance system. So if you have institutions that describe management plans for certain types of biodiversity, then you would expect that these represent the governance system of this biodiversity. And that's one of the most recent projects that I've been involved, is how do you link those? So first of all, I would like to take you back in time, still in the state of California, where about 1/3 of the state is now protected areas. So the green area here are not just forests, these are protected areas. And so one of my previous projects has been to reconstruct the history of protection in the state. So we have interviewed managers from all of these protected areas to ask them when did they acquire this land and what do they do in terms of management of this land. But what I wanted to highlight, because today I'm talking about how remote sensing can be useful here, we also have been able to digitize and georeference historical maps that depict land cover types from the 1930s and the 1940s and bring them to GIS and do a land cover change analysis. And this was one of the first outputs of the project. We looked into how the land cover change occurred in private land, so non-protected area, versus two types of protected area. A protected area such as the Bureau of Land Management, so a protected area that has some sort of management, and a protected area that is called wilderness. I don't want you to read this because I don't think it's possible. If you can do it, please tell me. But the idea is to show that private land and the two different types of protection have very different trajectories in land cover change. But what we've been trying to do is also to try to figure out, okay, we have land protection, but has this land protection been associated with regulations or governance institutions that protect species or that protect ecosystems? And so we created a visual environment, a web visual environment that you can explore and that allows you to look into detections of mammals, birds and plants as collected by different museums alongside with the protection of land. And so this is where we figure out when and where species are protected and ecosystems are protected. But today I wanted to highlight another issue here, and why do I consider this as a social ecological system? The state faces a big conundrum. In order for you to protect land, you have to purchase the fee. So you have to own land in order to then designate it to be protected. But the money or the funding to acquire land comes from development fees. So developers pay a certain amount of their profit to develop land to the cities who actually manage the land use rights, and then this money, part of it, goes to an agency to acquire conservation land. So this is a problem. In order for you to conserve and protect land, you have to allow a certain type of development. And this is really what I have been studying, is how has these dilemmas been really solved. So the first thing was to really chart out the different regulations that either protect natural resources or are for development. And the key part here is to look back in the earlier ages of the state in 1914, when the charter cities get power to decide over land use. So this power has not been revoked over the last century, and this created really the headways for our other project, where we looked into the combination of city and nature. And so what we wanted to describe was, is the language of planning at the city level, who is mandated to plan for land uses, matching the percent of open space that exists within the city. And we use remote sensing to look into percent pixels that are green and percent pixels that are paved to see if there was a correlation. So what we did was to look into the plans from many different cities across the US, and we use text analysis to look into the language of planning. So what does this, what we use is called topic modeling, and it's basically similar to a cluster analysis that looks into different words that are used throughout the plans and tries to cluster these words into different topics. And so we identified two topics that are related to biodiversity conservation, which we call parks and open space and habitat. Through this analysis, we then looked into where within the entire plan are these topics being mentioned. So what we find is that parks and open space are mostly mentioned in the section devoted to community facilities, whereas habitat is mostly in the section devoted to critical and sensitive area. And then what we linked, so this is all web-based and you can go explore, then we linked this information from the plans with several characteristics, biophysical characteristics of the cities, which are the amount of greenness within the city, the percent park, the amount of park need as identified by the Trust of Public Land, but also with many demographic characteristics obtained from the census. And so what we see is that, at least for the cities in California, the amount of words that mention parks, that relate to this topic of parks and open space or habitat, does not correlate with the current area that were dedicated to parks within the city. And then we also did not find any correlation with the distance to green areas or to distance to bare land. So what this suggests is that what is being talked about in the plans does not match the biophysical characteristics of the cities. So this creates really a problem, as the cities are the one mandating to the land use, and there is no consistency across cities. Where do they talk about and how much do they talk about nature protection and biodiversity and parks? We also created a web explorer, which you can look at it, that really gives you information on all the demographic parameters for each one of these cities. And then my final topic of today is really the part where I'm mostly invested this time. So how do we use, what are the remote sensing opportunities to think about the users of these resources? And this is what I call people. So one approach is, I've already mentioned the impervious surface. One approach is really to use impervious surface to map urban expansion over time and link it to protection expansion. And this is what we did. This was part of an exhibition at Oakland Museum of California of the expansion in urban and highways and conservation areas in the Bay Area. So we retrieved historical maps and we correlated those to remote sensing estimates for the latest to look into urban expansions. We then also looked into census data to try to see if the census data could explain our history of land protection. And disappointingly so, we found no correlations between census data such as percent income or population densities or different types of uses. And the only correlation that we found was that there was more conservation in counties where there was less proportion of their population in the cities. This could be because the county was either protected too early before there were cities, or because people in the cities could devote their rights to other types of activities rather than open spaces. So this is really what I had to say today. So I took you through my mental map of how I see biodiversity being integrated within this theoretical framework of social-ecological systems. I mentioned to you certain existing techniques or opportunities to integrate remote sensing in terms of the pixels, the plants, and people to understand these complex social-ecological problems. I think that remote sensing gives us a very strong benefit because it gives you the spatial context in which these decisions are being made. It gives you information of ecosystem processes spatially, but also temporally. And it allows us, as of now, understand the evolution of the social ecological system outcomes. My next steps in terms of the research is really to develop these more integrated models. So modeling the social system and coupling it with ecological processes to really look into the coevolution of the socio-ecological system. Because right now I only have the outcome, but now I want to expand beyond the outcome to try to understand where in time have this system led to where we are today. So with that, I would like to thank you, and I welcome questions.
¿Preguntas a alguien? ¿Comentarios?
Um, how do you integrate the variables when not have in across the time? I mean, when I have data in for months or every month, not daily or in the time more more ¿cómo sí, más seguidamente, o sea, datos más constantes en lugar, exacto, cómo integrar estos datos faltantes que tenemos, por ejemplo, en trabajo en la cuenca de Chiapas, pero hay datos mensuales o tal vez por temporada, pero no hay datos diarios. ¿Cómo podríamos integrar estos datos con algún modelo de espacial temporal? ¿Hay datos en internet?
So it depends a lot on the time frame of the process that you are interested. Okay. It's not about what's the frequency of the data that you have, but what is it that you're trying to study and what's the right time frame at which you can study it. And then of course if you only have yearly data or monthly data, depends a lot. You have to use that data because you cannot create. The other way to think about it is to create trends across your monthly data and use the trends to inform your process. But it's really about thinking about what is the temporal extent and the fluctuation of the process that you're trying to look, and try to match the data with the different events over the timeline that you have.
Thank you.
Hi. I have a question about pixels. My question to you is, you used Landsat, right? And I'm assuming you started using from the 70s up to today, right?
Last 15 years.
15? Okay, so it won't work, my question, because from Landsat 3, 4, and 5, we had a different spatial resolution. And my question to you would be, what do you do when you are comparing those images from Landsat 3, 4, with the images of today, with a different resolution?
So you have two options. So either you upscale the most recent data to match the resolution of the historical data, or you can use something like spectral unmixing to tell you what's within a spectra, within a pixel, that matches the resolution of the most recent data.
Hi. I have several questions, but I'll just ask one for now. So at the end of the first part, when you're talking about cork, the oak woodlands in Portugal, you said that in the end you were doing a social component where you're interviewing the cork producers to see what their actions were like in the face of the different changes in the landscape. So do you have a plan on how to integrate that? Are you going to integrate that data into the analysis that you're already doing, or how do you think to couple that data into your analysis?
So that's next year's plan. We have a grant starting to go back to Portugal and to collect data. So we have several long-term ecological research sites in which we have the remote sensing part of it, and in which we have been interviewing different stakeholders to try to integrate them. Right now it's still a very correlative analysis, but we want to move it to become a more predictive and eventually a process-based model.
We can talk more about that.
Yes.
Pues me da la impresión de que la parte social de social-ecological systems, pues todavía no es posible integrarlas en píxeles, ¿no? O sea, como que esa parte pues sigue siendo sujeta a trabajo de campo y a integrar esa escala de trabajo de campo que es mucho más fina con las diferentes escalas del análisis de mapas, ¿no? Que sirven mucho más para la parte ecológica de los sistemas socioecológicos. Entonces quisiera oír tu opinión al respecto, ¿no? Porque yo vine esperando como algo más de el uso de remote sensing para la parte social, ¿no? Y me parece que tiene muchas dificultades y quisiera oír tu opinión al respecto.
Well, that's exactly what we've been trying to do. Is like, obviously, remote sensing started off with a lot of ecological applications and Earth observation in terms of the processes of ecosystems and their change. For social processes, some social processes are aspatial, so it's very difficult to think about them from a spatial perspective. But what we're trying to explore here is whether there are proxies from the remote sensing that could identify those processes. I don't have an answer just yet. What I've showed you has been our best attempt to link plans and different ways that people use the landscape. One other avenue is to think about productivity and cork harvest and how does that relate. And one other possibility that people have been exploring is to track people and use the same type of analysis that we do for wildlife habitat relationships to try to see what people do in the landscape. So that's also a possible next step. People have been using either phone trackers or cell phone trackers to see where people go when they go into the landscape. Because what we think right now is that just asking surveys is not sufficient. We want to be able to track what people actually do on the land when they go to the landscape. Unfortunately, my student was not able to get permission from the people to follow them around because that was the first idea. I have another student in northern Italy. She's tracking cows as they are moving around through the landscape to try to get more at these spatial processes. But yes, that's really the challenge. I think that there are limitations to which extent can you map the social system, but there are also other avenues through these proxies that try to integrate the users with the system itself.
A very interesting presentation. I was wondering about when you talk about the coevolution of socio-ecological systems, what's it like the time scale you are trying to, like is there any time scale because I mean usually, you know, I guess some of these processes can take maybe decades to understand or to study. So I was wondering if, for instance, if you go to remote sensing, that most of the products available right now, they have maybe 20 or 30 years of data. How do you compensate for this lack of, I mean, you cannot go, you know, to reconstruct maybe 100 years ago what was going on.
Well, actually you can use models to do that, and that's what they have been doing in the Netherlands. They just reconstructed the European landscape for the last 100 years. So what's one possible avenue to compensate? So yes, I think the timeframes can be very long, depends again. So for the conservation timeline, what we see are several important events that lead to certain changes in the social ecological system. So you can start by first identifying what are these events that create the change, and then eventually model the landscape before and after to try to get at it. But of course, there are limitations looking back in the past, but there are also limitations in projecting into the future, so we have to work with our best available set of tools, which is using remote sensing very finely more recently to create these models to be able to project either backcast or forecast what we know from the remote sensing, and then linking that with the social processes. I find it more challenging is the time frame in which ecosystem processes operate versus the time frame in which social processes operate, and that's really where the challenge is, in my opinion.
Yeah, and I also have a question regarding, like, well, now you mentioned that you can also, you can combine models with observations from remote sensing. So Is there like in your studies, have you found like a lot of uncertainty between both like the output? I mean, what you observe from the satellites or from remote sensing and what you see from the models?
Yes, and so that's one of the reasons why people haven't been modeling things at less of a time step of 10 years, because ecosystem processes don't really operate at a finer time scale. And so it depends a lot on what the question is. Of course, the models have uncertainty. The remote sensing data also has uncertainty and limitations. So we have to be very explicit to what we can do and what we cannot. It's the same, I find it's very similar to climate models. It's
exactly.
The same idea, uncertainty, and the more models there are out there for mapping land cover change, climate models are an ensemble of 20 or thereabout, and they all have different priorities in different formulations, and we just look at the ensemble and not at any one model individually. So that's the same, at least in my opinion.
Thanks.
So another question that was sort of alluded to in previous questions is about the scale that can be operated and the difference between governance systems and scales like you were saying counties or different kinds of límites, borders of governance systems, and how that can be reconciled when you have spatial data that works at a different kind of scale.
So that has been one big challenge. So one of the reasons we picked the city plans is because it's a confined boundary, and we know these plans relate to a given jurisdictional boundary. But you have different institutions and different regulations that operate at many different boundaries, and so the alternative to look at it from just a pure spatial scale is comparing a control and a treatment system where you have this institution in place versus where you don't have the institution in place for the same ecosystem, and you compare the two of them.
Bueno, pues si no hay más preguntas, quisiéramos agradecer a la doctora María Ferreira por estar aquí con nosotros. Gracias. Gracias. Perdón, me recordó Amy. Esta es la primera de una serie de pláticas, seminarios de discusión para los tutores que va a haber con invitados de diferentes lugares del mundo con programas similares al nuestro. Similares, todos tienen diferencias, pero con algunas cosas comunes, tratando de llegar a temas de sostenibilidad. Entonces, María es nuestra primera invitada. Dentro de un mes vamos a tener al doctor Andy Stirling. ¿Qué día de octubre? 10 de octubre. ¿No? El 10 de octubre. Van a estar aquí, los estamos invitando por 3 días. Entonces, lo que está sucediendo es que platican con los tutores, están con el comité académico, dan una plática de sus líneas de investigación y les dan una clase a los alumnos. Entonces es como varias maneras de interactuar con ellos, escuchando a qué se dedican ellos y cómo se relaciona con los temas de sostenibilidad y cómo operan en los otros programas. Hoy tuvimos una reunión con el comité académico y María nos expuso cómo era su plan de maestría, cómo era la evaluación de los alumnos, cómo los diferentes tutores de diferentes áreas evaluaban las tesis. Entonces esto va a ser muy interesante si vemos cómo operan este tipo de programas en otros lugares del mundo. Entonces están invitados, esta es la primera serie, en un mes tenemos la que sigue.